Okay, welcome to block 4. So, first we discuss about what we have covered in the block 3. So, we discussed quickly about faceting. So, we could have two type of facets. One is the facet wrap, which is one dimension, or we could have facet grid, which is two dimensions. We also explored many themes, so you could have like different kind of themes across your ggplot. So for example, we have seen the minimal, the black and white, darker, gray theme, void, so not to make any themes. We also understood about the how important the colors are, and we have explored different colors using our color brewer and VT's packages. We also last time we also discussed about how to save the plots and what kind of different formats of the plot like PDF, TIFF, PNG, and we understood that if you want to save a PNG plot, it's always good to use the DPI option to set the high quality so that it is not pixelated when you change the size of the plot. We also looked into if we want to change the theme, the overall font type of the plot, for example making it Times New Romans, or if we want to change certain elements, for example the text size, etc., and changing for example the axis. We have also looked into how to make a specific ggplot an interactive one for exploratory purpose. Now today we are going to cover about statistical annotation and summaries. So this means, for example, sometimes you have to plot the p-values, or you have to mention the p-values. When you do a correlation analysis, you have to put the correlation values in the plots, or you make, for example, the confidence intervals, etc. So we are going to discuss the basic ones. So first of all, what is a confidence interval? So it's a range of values that likely to include a population value within a certain degree of confidence. So it measures basically uncertainty around an estimate, and that could be, for example, between something. If you have the value of 0.5, it could be 95% of confidence interval, which could cover the uncertainty basically. So if you were have to take 100 different samples and compute a 95 CI for each sample, then approximately 95 of the 100 confidence interval will contain the true mean values. Now, the reason when you should include it is when you want to show the uncertainty of a statistical estimate such as mean or regression line. So to add these statistical summaries in ggplot2, you could use different functions, for example geom_smooth. So this geometric function adds a smooth conditional mean like a regression line, and you could specify which kind of method you want to make use to make these lines. For example, the linear models, generalized linear models, generative additive models, or Loess. You could also use the show the confidence interval by geom_smooth. So let's look at a example here. So the question here is if there is a correlation between log-fold change at 3 hour and 24 hour after sucrose treatment. So we are using the ggplot2 for making the plot, and we use the diff table. So if you remember, the diff table have the different statistical values, for example the log-fold changes and p-values. And using this data, we are saying we want to, because we want to test after sucrose treatment at 3 hour and 24 hours, so we just make on x-axis this log-fold change coming from 3 hour, and y-axis with sucrose 24-hour log-fold change. And then we are going to set the alpha. So we are going to make, we are making the dots, so each dot here, and then we are just setting that 50% of the dots are should be transparent. So there is a 50% transparency of the dot size so that we could see the overlapping if there is any. Now we are going to fit a line with the linear model, and this will also add the confidence interval of 95. So we could see that with this function we have seen a blue line appearing here, and then there is a confidence interval in grayish color which is appeared here. Okay. Now, and what is the next? We are going to look at the correlation coefficient. So the correlation is basically measure of how two independent variables or two dependent variables are linked to each other, or how if they are into a linear relationship or not. So these values could range between 0 to 1 for positive correlation and 0 to -1 for negative correlation, where 1 represents the perfect positive correlation, -1 stating the perfect negative correlation, and 0 saying no correlation at all. So you want to show this or include this when you want to quantify the linear relationship between two numeric variables. So to include this, we could use a package called ggpubr, and it stands for gg publication ready r or something like this. And then it is basically provide functions, so it have wrappers around ggplot to make the publication ready figures. With this, you could add the p-values, the correlation coefficient, you could customize the plots with cleaner themes and arrange multiple plots as well. So to annotate the plots with statistics, we could use, for example, the stat correlation. So this add correlation coefficient and p-values, or you could use stat compare means, which adds p-values from statistical tests such as t-test or ANOVA. So first, the biological question remains the same. It's a bit different here that now we want to check for the correlation of the logfold changes at 3 hour and 24 hour. So we are going to load the package, and then the ggplot code remains the same, the geom alpha remains the same, geom point, and then we just say stat correlation, and you could choose a method, I think, between Spearman and Pearson. Now we provide the title, the x-axis and y-axis and all. So here, as you have used the stat correlation, it have automatically added the correlation value here, and also the p value here. Now you have noticed that there is no geom line, there is no blue line here because we have not added that. Now let's look at the example with stat compare means. We want to check if there is a significant difference between expression of specific gene between the none and sucrose condition. So what we are going to do is we are going to take the gene, a significant gene. So what we are doing here, from the differential table, we are selecting the gene with p-value of less than 0.05 and the absolute log fold change of more than 1, and then we are just taking the first gene ID. Now for this gene ID, what we are going to do is make a data frame here. So the expression would be where this gene is present, and then the compound and time. So this, we are just making the table, and then we filter out for 24 hours because we just want to see it between none and sucrose at 24 hours. So we plot the data, we define the axis as compounds and expression, and fill it with different compounds, so none or sucrose. Then we make the box plot, and then we say stat compare means, and we use the method called t-test. So as you use this, it will plot the t-test p-values here. Okay. Okay, so now what we want to do is, after this one, is to see if there is any significant difference in expression of a gene between different time points for the sucrose treatment. Okay, so we can compare it both at none and sucrose stage. So we select our gene based on the significance like the previous plot, and then what we are trying to do here is basically make the same data frame for the same gene with compound and time. Now what we have to compare here is between difference between 3 and 24 hours. So we're going to use the same ggplot2 function to make the plot. We define the axis of x-axis as time, y-axis as expression values, and we fill the boxes of box plot by time. Now we make the box plot, and then we split the plot by different compounds, so basically the none and sucrose. And now we use the functions that compare means, and then we are going to compare with the method t-test, and the comparison was between 24-hour and 3-hour. So with this you could see that we don't have any significant difference between any of these two groups, and that the p-values are represented on top for both the plot. So this is one way to add the p-values in of using t-test when you even want to make the comparison at different levels or different subgroups. So with this we are done for the block 4, and let's look at the exercise. So the exercise involve using the ggpub and these other packages which you have already used previously. So the data remains the same. The first exercise is to make a scatter plot with regression line. Again, you try to make the plot yourself. Otherwise, you could also look at the solution. This is more or less the same that we have seen in the course. Now the second one is to add a correlation coefficient. The third one to make the box plot with the p-values, and then we are also going to make the volcano plot. And you could see that the volcano plot remains the same, except that we try to add here is the top expressed genes. And we also, the idea here is to see if we could make the expressions on the x and y axis in a beautiful manner. So basically exactly how it is written in the figure. Okay, then there is again a plot for you to check the expression of two different genes, and then you could also see here how nicely the log2 is written and r is written and p is written to make the figure publication ready. Okay, with this we are done with the block 4.